Okay, so continuing as solving multi-step inequalities, just when it comes to multi-step, certain steps you do need to take as you're solving is step 1, distribute where needed, if possible. Then combine like terms on either side, and then move the variables to one side. And we've been doing it where we move the variables to the left side since we're so used to seeing that. And then it should become a simple two-step problem, so then you would just solve using SADMEP unless it's a special case. Just keep in mind also, if you multiply or divide by a negative, you also flip the inequality sign. So let's get started. Example 1. Okay, I see a set of parentheses, so there is distributing on this problem. So 7 times x is 7x. 7 times negative 3 is negative 21. Plus 9 is greater than or equal to 37. So I just bring down 37. I bring down the 9 because it does not apply to the parentheses. Then I look to see if I can combine like terms. So I do not combine anything with 7x on the left side, so I bring it down. Negative 21 and positive 9 are like terms, but read it from left to right. So negative 21 plus 9 is negative 12. Greater than or equal to 37. Then SADMEP tells me I take care of any subtraction or addition first. The inverse of subtraction is to add 12 to both sides. So I have 7x is greater than or equal to 37 plus 12 is 49. Divide by 7 to both sides. I didn't divide by negative, so this means this inequality stays greater than or equal to. 49 divided by 7 is positive 7. And there you go. Continuing. I see a set of parentheses, so I do distribute. 2 times negative 1x is negative 2x. 2 times positive 4 is positive 8. I bring down minus 3x because it does not apply to the distributing property. And 43 on the right side. I combine like terms where possible. So here I have negative 2x and negative 3x are like terms. If I read it from left to right, I do negative 2x minus 3x is negative 5x plus 8 is less than 43. Then it becomes a simple two-step. So SADMEP tells me I take care of addition first. So the inverse of addition is to subtract 8 to both sides. Negative 5x is less than 43 minus 8 is 35. Then I divide. Be careful, this is not subtraction, this is multiplication. The inverse of that is to divide by negative 5. Okay, when I divided by that negative, it flips this inequality to greater than. 35 divided by negative 5 is negative 7. Continuing on to example 3. There is no set of parentheses here, so I do not distribute. But I do see if step 2, if I can combine like terms where possible. If I look on the left side, I have negative 5x and minus x on the left. If I read it from left to right, negative 5x minus x is negative 6x minus 7 is greater than. There's no combining like terms on the right side, so I'm going to bring it down. Then, this is the step that we haven't seen yet on example 1 or 2, but I need to move the variables to one side. And we're so used to seeing the variable on the left side, so I'm going to move this minus the negative 2x. To move a negative 2x, we have to do the opposite, which means to add 2x, okay? And that gets added to the negative 6x. Negative 6x plus 2x is negative 4x. Minus 7 is greater than. These x's cancel, and all I have is 17 on the right. Then it becomes a simple two-step. So the inverse of subtracting 7 is to add 7. Negative 4x is greater than 17 plus 7 is 24. And then I divide by negative 4. The second that I divided by that negative 4, that means flip the inequality from greater than to less than. 24 divided by negative 4 is negative 6. Continuing to example 4, there is no distributing, but I do check to see if there is combining like terms on either side. I have 5x and negative 8x. 5x minus 8x is negative 3x. Minus 4, bring it down because it does not combine with anything. On the right side, I have negative 4 plus 3x. Because I just bring it down because there's no combining. Now I want to move the variables off to one side. So I'm going to move positive 3x to the left. The opposite of positive 3x is to subtract 3x to both sides. These do not cancel. Be careful here. This is negative 3x minus 3x is negative 6x. Minus 4 is less than or equal to negative 4. Okay. Then becomes a simple side map. So the inverse of subtracting 4 is to add 4 to both sides. So I have negative 6x is less than or equal to negative 4 plus 4 is 0. A lot of people think because they see the 0 that I'm done, but I don't have x by itself yet. So the inverse of multiplying by negative 6 is to divide by negative 6. Since I did divide by that negative, it does still flip this inequality to greater than or equal to. 0 divided by negative 6 is 0. Okay, continuing on. This one seems like a doozy because it sure is when we're dealing with fractions, so bear with me as we work through this. There is no distributing because I do not see a set of parentheses. There is no combining like terms because there's nothing to add or subtract on either side. So my third step says to move any variables. So this is where we need to be careful with fractions. I still need to move a variable. So I need to move this variable over to the left because we're so used to seeing it on the left. The opposite of positive 2x thirds is to subtract 2x thirds. Okay, so this is 5/6x minus 2/3 x, same thing. So in my calculator, I'm just going to do fractions. 5/6 minus 2/3, and I get 1/6 x plus 1/2 is greater than or equal to 4 because those 2/3 cancel. Then it becomes a simple two-step with fractions. The inverse of adding 1/2 is to subtract 1/2. So I have 1/6 x is greater than or equal to 4 minus 1/2 is 3.5, but I'm going to double check. 4 minus 1/2 is 7/2, which is just, it's 3.5, but it's written as improper. So we're going to go ahead and leave it as improper because we don't want to write it as a mixed. Then the inverse, or I would technically divide by this fraction here, but when I divide by a fraction, the rule tells me that I flip it and multiply. So I'm going to actually multiply by 6/1 to both sides. So x is greater than or equal to 7/2 times 6/1. If you want to trust your calculator, is 21. So after all of that, we don't even end up with a fraction in my answer. Okay, seeing that same idea with this problem, so same idea here. I do not see any distributing. There's nothing to combine on either side, but I do want to move this variable over to the left. The opposite of positive x is to subtract x to both sides. 3/7 comes down. Then I try to figure out what 9/14 x minus 1x is. So I type it in. Okay, minus 1 is negative 5/14. It's crazy fractions. Is less than 1/14. Oh my goodness. Then I want to, it becomes a simple two-step problem. So I need to get rid of this, move this 3/7. So the opposite of positive 3/7 is to subtract 3/7. Crazy fractions, crazy fractions. So I have negative 5/14 x is less than 1/14. So I would use your calculator if I were you. Minus 3/7 is negative 5/14. Okay. Here I see multiplication, so I would divide by negative 5/14. When I divide by that fraction, I flip it and multiply. So I'm going to flip it and multiply by negative 14/5. So x, because those cancel, since I multiplied by a negative, I need to flip my inequality. And I have negative 5/14. Oh my goodness. Nope, not 12. Oh my gosh, not 12. Times negative 14/5 simply comes out to positive 1. So there you go after all of that. Okay, so getting away from fractions there, let's keep practicing. I feel like I saw these. Okay, take care of any distributing where possible. So I can distribute on the left side. 6 times x is 6x. 6 times positive 3 is positive 18. I cannot distribute over here on the right, so I'm going to just bring it down. My second step says that I combine like terms. There's nothing to combine on the left side, but there is something to combine on the right side. So 5x plus x is 6x plus 17 comes down. So I have 6x plus 18. Then I move the variables to one side, so I'm going to need to move this 6x over. The opposite of positive 6x is to subtract 6x. But look what happens here. So I want us to be extra careful here because we've seen this before, but we haven't seen it with inequalities. So 6x minus 6x cancels, and I'm left with 18 is less than 6x minus 6x also cancels, and I'm left with 17. Okay, but look at the statement. This is where you ask yourself, is this true? Is 18 less than 17? I did all the math correctly, but is it true? Since it's not true, okay, we've seen this before with solving regular equations. This is called no solution, okay, or empty set, or I think that's it. But no solution, the symbol that we see often is a 0 with a slash through it, so empty set, okay? So that's a special case. Example 8, I take care of any distributing where possible, so 3 times 3x is 9x, 3 times positive 2 is positive 6. Nothing to distribute on the right side, so I'm going to bring it down. Then I look to combine like terms. There's nothing to combine on the left, so I bring it down. On the right, I can combine 4 and minus 3. 4 minus 3 is 7 plus 9x. Then I want to move the variables over to the left, so I want to move positive 9x over by subtracting 9x. So 9x minus 9x cancels, and I'm left with 6 is greater than or equal to 7. 9x minus 9x is, I feel like something's wrong there. Oh, I did that wrong. That's 1. Sorry. 4 minus 1 is 1, not 7. 4 minus 3 is 1. And then 9 minus 9x cancels. So ask yourself this question. Is it true? Is 6 greater than or equal to 1? And it is. With this statement being true, we have what we call infinite solutions. Okay, or we use the infinity symbol. But most commonly in algebra, we see what we call all reals, which is a double/r.